Hello students, how are you? Today we discuss the matrix and determinants applications both, that consistent and inconsistent system of equations. The consistent equation means the equations which have at least one solution. That means the solution must be present, and in inconsistent there will be no solution. So at that time, maybe it's a infinite solution or no solution, whatever be any condition. Now, with the example, we find out the consistency and inconsistency. And examine the consistency of the system of the equations x plus 3y is equal to 5 and 2x plus 6y is equal to 8. There are two equations. And in this equation, for the consistency and inconsistency, we just find the determinants of these equations. For the determinants of the equations, we just first of all in the first row take the coefficient of x and y, means that is 1 and 3. And in the second equation, we just take the coefficients of x and y, and that is equal to 0, and means it is inconsistent. Similarly, here we can take b is equal to this determinants of b, that is 1 and 2 and 2 and 3, that is 3 minus 4 is minus 1, and this minus 1 is not equal to 0, and when it is not equal to 0 means case of consistency. So this is the consistency and inconsistency examples. Now in the example 2, solve the system of linear equations. Linear equations means what? Linear equations means x, y, z values are, the powers are always 1. So the first equation is 2x plus 3y plus 3z is equal to 5. The second one is x minus 2y plus z is equal to minus 4. And this 3x minus y minus 2z is equal to 3. This is my equation 1. This is my equation 2. Here equation 3. And first of all, let x is equal to x, y, z, and a is equal to all the coefficients of x, y, and z, and consider. So that is 2, 3, 3. And 1 minus 2, 1, and 3 minus 1 and minus 2. This is my third column. And after that, the b value is all the constant terms of the right hand side, that is 5, minus 4, and 3. Let us see one by one the cofactors and determinants value. So the value of determinants A we can find that 2, 3, 3, 1 minus 2, 1, 3 minus 1 minus 2. Simply we find the determinants value. So that is equal to 2 minus 2, 1 minus 1 minus 2 minus 3, 1, 1, 3 minus 2, and plus 3 is equal to 1 minus 2 and 3 minus 1, and therefore that is equal to 2 into 4 plus 1 minus 3 minus 2 minus 3 plus 3 minus 1 and plus 6, and this is equal to so this is equal to 2 into 5 minus 3 minus 5 plus 3 into 5. This minus 1 plus 6 is equal to 5, and therefore so 2 into 5 is 10, and this is 15, and this is 15, and therefore the value is equal to 40. So the value of determinants is 40. So we will write here that determinant's value is equal to 40. Here, first of all, we find the cofactors. So this is A11 is equal to here's minus 2, 1 and minus 1 minus 2 is equal to 4 plus 1, 5. A12 is alternate positive negative, so that is 1, 2 is equal to 1, 1 and 3 minus 2 is equal to minus 2 and minus 3 is plus 5. A13 is equal to plus, this is equal to 1 minus 2 and 3 minus 1 is equal to minus 1 and this is plus 6 is equal to 5, because this 3 and minus 2 is minus 6 and minus becomes plus. So that is minus 1 plus 6 is equal to 5. Now what's about the O21? A21 means this is second row and first column. So that is equal to 3, 3 minus 1 minus 2 is minus 6 and that is equal to plus 3 and therefore it is plus 3. This A22 is equal to plus this A22 in second row and second column. So this take the 2, 3 and 3, 2 and that is equal to 4 and minus 4 and minus 9 is minus 13 and A23 is minus, this A23 means third row, second row and third column is 2, 3 and 3 minus 1 is equal to minus 2 and minus 9 is plus 11. And after that we take this E31 is equal to plus, this A31 means third row and first column, that is 3, 3 and minus 2, 1 and therefore it is written as 3 plus 6 is 9 and this 3 to 2 is equal to minus this third row and second column, that is 2, 3 and 1, 1 and therefore it is 2 minus 3 is equal to plus 1. So A33 value is 2 minus 2, 3 minus, that is equal to minus 7. With the help of this, we find the adjoint. Here, now we find the A inverse, that is equal to adjoint A upon determinants of A. So this adjoint A value is equal to, here's 5, 5, 5 in the first column, 3 minus 13, 11 and 9, 1 minus 7 upon the value of determinants is 40. We already discussed about this one factor is Ax is equal to B, and we already suppose that what is A, what is X and what is B, and if I multiplied in both sides, this X is equal to A inverse B. So this A inverse and A are equal to I is equal to A inverse B. So this Ix is always equal to X, A inverse B. We use this factor, X is equal to A inverse B is just like this, and this is equal to X, Y, Z. A inverse I just find out, 5, 5, 5, 3 minus 13, 11, 9, 1 minus 7 and upon 40. And the value of B is equal to 5 minus 4 and 3. When we simplify this one, this is equal to 25 minus 12 plus 27, and this is 25 plus 52 plus 3. This 5 is multiplied with 25 minus 44 minus 21 by 40. And that is equal to, here's 40, and that is equal to 80, and that is equal to minus 40 upon 40, and therefore it is equal to 1 to minus 1. So the value of x, y, z is equal to 1, 2 and minus 1. So this x, y, z is equal to 1, 2 minus 1, or x is equal to 1, y is equal to 2 and z is equal to minus 1. So this is the value of x, y, z. We confirm that if we put x is equal to 1, y is equal to 2 and z is equal to minus 1, we get the required result of right hand side. Just put these values and equal to 5. So now we conclusion with our consistent and inconsistent, and next time we discuss about another topic.